right, ladies and gentlemen, this is a procharger, and this is a lathe, and this is a procharger hooked to a lathe, and this is a procharger hooked to a lathe, hooked to a test pipe, hooked to an intake that we just fabricated on this video. And today we're going to compare it to some other intake manifolds and show you why the Dual Plenum Intake is superior to any other intake. Spicy. If you guys followed our 5-cylinder Atlas build that we did in my Ford Fairmont station wagon, you will have seen that we did a dual plenum intake manifold. And today I want to go way more in depth on how these intake manifolds work and why you should do one on your build. The 5-cylinder combination that we did in my Fairmont has been one of the best performing combos that we've ever done with an Atlas engine. And I think that is largely due to the dual plenum intake manifold that we built for that car. But how do these things work? Let's talk about it. All right, so let's get you guys in close here and show you how this works. Basically, this manifold consists of a primary plenum like this, and it has a tapered cone as it goes back. This tapered cone uses Bernoulli's principle to basically maintain the velocity as the volume of air is being consumed by each cylinder. Basically, it's like a distribution header, and it's kind of like what you see on like air handlers used in buildings. As it gets further and further away from the circulation fan, the cross-sectional area of the ducting will neck down to maintain velocity. So basically, as the cylinders consume air, we get to a smaller cross-sectional area, and that causes it to flow into the secondary plenum with a nice and consistent velocity. This consists of the primary plenum and the secondary plenum, or the pressure box as they call it in the instructions. If we look down inside of the plenum, you can see there is a nice air slot for the air to basically go from the primary plenum into the pressure box. And something else to talk about here, if you listen to some people who talk about intake manifold design, they talk about how having a nice parallel face here for the pressure waves from the intake manifold to sort of reverberate off of actually is very beneficial for an actual running engine. This is something that's really hard to simulate in CFD and really requires that you actually run it in an engine. And I think that is one of the reasons why this works so well. Some people say that a dual plenum intake is kind of like ITBs, or individual throttle bodies, which you see on a lot of max effort and naturally aspirated combos. The dual plenum is the ITB for a boosted engine. Now, what you're looking at here is a kit from the guys over at MW Steel. It's a company out of Finland who primarily makes parts for rally cars. And that is where the dual plenum is typically used. In rally car racing, you're wide open throttle for minutes at a time. So a little bit of inconsistency in cylinder to cylinder distribution is something that you really need to pay attention to on a rally car, because that little problem turns into a big problem if you're not careful. I think that there are massive benefits that you can see on a drag car as well, especially a high horsepower, small cubic inch engine like this, which is why we explored it on this combo. Now, obviously, this isn't already completed intake, but I am going to go back in time to when we actually started to put this thing together, and I'm going to show you exactly what you get in the MW Steel kit and how to build an intake manifold like this for yourself. So let's get to it. All right, ladies and gentlemen, before you start on your intake manifold, I'd highly recommend that you read the instructions. I know, who wants to read the instructions? Well, in this case, they're actually very detailed, and they actually give you reasons why they recommend that you do a particular thing, rather than just telling you to do it. In fact, I learned a few things when I read this. One thing that it recommends is that you use 5356 weld rod, and the reason for this is that 5356 is stronger than your more typical 4043. It's about 50% stronger, and when you're running a lot of boost, like we plan to in this particular application, it's a good idea to make that weld as strong as we can. Also, it gives recommendations on how to prep the material. It says that you should not use a sanding disc in order to prep the material. Sure, you can use it to sort of shape the material, but for final weld prep, you should use a hand file. I didn't know this, but the sanding disc can actually get oxide and whatever the media that's used in the sanding disc can get that down into the metal and possibly contaminate your weld and make it weaker. So next, let's show you guys what's actually included in the kit, and then we can get into fabrication. All right, this is how the kit comes shipped to your door. I've actually unwrapped a few things in here, so it does come wrapped up in some nice plastic, so don't worry about that. But first off, you can see it has the two halves for the secondary plenum. This is the plenum that is matched up to the runners that actually run into the engine. Now, inside here, this is where the magic happens. This is the tapered cone for the primary intake plenum, and then there's sort of an extension piece here that goes onto the front of it, which you may or may not need depending on your engine configuration. Then from there, it comes with a bunch of support rod material so that you can add support rods as needed. If you're running a very high boost application, they recommend inserting these support rods down inside of the plenum and welding the ends. We'll get into that a little bit later, more in detail, but the last component that we have to talk about is actually this piece right here. This piece is used to cap off the end of the primary intake plenum and sort of complete the plenum for optimal flow and appearance. I gotta say, really nice kit. I'm super happy to be working with these guys, but next, let's get into some fabrication. I should mention that this is just an intake plenum kit. It doesn't include anything that you need for the intake runners on your engine. They do have some kits for a particular engine choice that have the runners and some velocity stacks, but unfortunately, they don't support a Vortec 4200. I know, darn. But that's okay. We can use our billet intake plenum set that we've used on several engines thus far. And because we are using these intake runners, we're gonna go a little bit off of the reservation with the instructions. All right, I've modeled up the intake manifold so that I can give you guys the recommended method of construction for the intake manifold. So first off, you're going to start with your two plenum halves. You're going to want to true them up and get them ready to be welded together, but you're not going to weld them together quite yet because you need to drill holes in the one plenum half to accept your intake runners. Also, you're going to want to cut your air slot, basically the entry between the primary plenum and the secondary plenum. The instructions are very clear about how they recommend that you cut this slot. You can either do it squared off, or you can do a tapered shape like what you see in the CAD model. Once that's done, we can start with the first weld on the intake manifold. And that will be to weld your intake runners to the plenum half that you had just drilled holes in. And you're also going to want to weld any velocity stacks inside of the plenum to the manifold half. The reason that they suggest that you do it in this order is because you're not going to be able to get these velocity stacks up inside of the plenum if you weld the other half to it. This air slot here is not big enough to squeeze stuff in, so you kind of have to do it in this order. Now, something that they recommend that you do is that you make sure that your velocity stack has enough space between the outer plenum face and the entry to the runner They recommend an 1.5 inch clearance between the two, and that is to give the air plenty of room to get up and into the velocity stack. As you can see, I've modeled this with plenty of space there, but you can make it a little tighter if you want. Just make sure you leave enough clearance. Next, we can weld the two plenum halves together, and then we can start construction of the primary plenum. So it consists of this part here and this part here. Now you can drill holes in this area right here because later we will be inserting some support rods through there, and you can use those holes with some bolts to help to squeeze this part of the plenum together and allow you to line it up easier with the secondary plenum. Once that is done, all you need to do is weld your little end cap onto the end and weld the little face piece that they supply into this area here. And then you can add the support rods as you see fit. Now we're going to be doing our construction method a little bit different. Because we already have a billet intake runner with a radiused entry, so we're actually going to weld the two manifold halves together first, and then we will cut a window into this. This will give us the opportunity to weld both the outside of this plenum as well as the inside once we cut that window into the intake manifold. So let's get this clamped up and weld our secondary intake plenum. Let's drop that. Alright guys, next we are going to cut our hole into the plenum to fit our billet intake runner set. Now you'll see that the corners here stick out a little bit on either end. So what I'm going to do is I'm going to round the corners here. This will also reduce the chances of it cracking, just because the rounded edge will help distribute the load a little bit better. Here is what we got. I left the hole a little bit small. We will trim it out to fit our billet intake runners. But the reason that I did this is because now I can get inside of here and I can weld all of these seams from the inside. This will ensure that the metal is stuck together really good and hopefully keep this thing from blowing apart. All right, the kit recommends that you put rods in the air slot to help keep the thing from blowing apart when it's under lots of boost. We will be doing that at a later point, but for now we can drill the holes for these rods because that's going to help us to assemble the thing. Basically, we're going to put bolts in between here, and that will help us to draw this in so that we can get it to sit down and sit in the right location without issue. So let's go do that, and then we can get this thing welded together. Alright, now that we have the two plenums welded together, we can now put our support rods into the intake manifold. Now it's very important to not trim these too short. You don't want to make this rod like flush with the manifold as it sticks through. You actually want it to stick out a little bit. And the reason for that is that if it's flush up against, the part that's down in the manifold will get shrunk up because the weld will draw the rod up into the weld, and that will weaken the rod and make it less effective. So we want to stick this through the hole and then mark it a little bit extra long. And then you want to make sure that when you're doing the weld, it goes up into the part that is sticking out and not down into this inside of the plenum. So let's get that done. And then we can move on to welding this manifold onto our intake runners. So let's get to work. Alright, here is what we ended up with. I am super happy with how this came out, but before we end the video off, I want to show you guys a little test that I came up in order to show you how well this dual plenum intake works. So let's go to that. Alright, so some of you might be looking at this and might be saying to yourself, what the heck is going on here? Well, one of the steps in the instructions is it says that the functionality of the intake manifold can be verified by measuring individually the air mixture from each exhaust chamber. And in the case of fuel injection, you can offset your injectors to match the amount of airflow into each cylinder. But I'd like to do it a different way that doesn't involve running the engine and, figuring it out that way. Basically, I need an airflow tester. I've done this in the past using a squirrel cage style blower hooked to an electric motor, and it didn't really work too well, and I think it was because we didn't have enough volume. So the idea with the procharger is we should be able to get plenty of volume with this thing. Then you can use an airspeed sensor, kind of like this one, which I'm going to link one in the little YouTube shopping thing for something that you could use as like a track weather meter. So if you guys want to get a hold of something like this for yourself, that's a great way to do it. But basically, we can take this airspeed sensor, and I have 3D printed this manifold here, and then it lets you basically match up your airspeed sensor up to your intake port, and we should be able to measure the airflow coming out of here. Now we can take this cross-sectional area here and multiply it by the airspeed that we measure, and that will give us a volume flow rate. So we should be able to measure the volume flow rate going through each cylinder, and that should give us an idea of how evenly the air is being distributed through the intake manifold. So let's get to work. Spicy. I did this testing at 3 different shaft speeds on the procharger just because I thought it would be interesting to see if the trend of the airflow distribution through the intake manifold changed with different air speeds. We also tried it with the center feed intake manifold that we ran on my Fairmont a while ago, and we also tried it with a forward-facing intake manifold as well. And here are the results. As you can see, the dual plenum intake is not performing how it probably should, and I think that needed more investigation. The center feed was performing the best by far, and the front feed, well, that thing's kind of a disaster. But back to the dual feed. I really think that there is a problem, and to figure out what is causing the problem, we needed to jump over to a computer simulation with a tool called CFD. All right, guys, I think the method of testing that we were using there on the lathe was not a really good test. And to prove it, I have moved the intake into a simulation on my computer. Basically, I took the dimensions of the intake manifold and I duplicated them on my PC so that we could use a CFD tool, or a computational fluid dynamics tool, in order to sort of look at the behavior of the manifold. Basically, what I think the problem is I don't think we can get this intake manifold into the flow situation that you would experience on an engine and do so very accurately with the way that we were doing it. Now, just to prove out the simulation, I basically modeled up the exact scenario that we were doing on the lathe, and I ran it through the simulation just so that we can get comfortable with the simulation and just be comfortable that our future conclusions actually hold water. So I have the amount of air that we were flowing into the intake manifold flowing into the tube here, and then I have run it through the CFD program, and I have measured the airflow that is coming out of each one of these ports, and we're coming up with fairly similar numbers. Granted, they are not exactly the same numbers, but you at least see the general trend of the back cylinders are getting more air than the front cylinders. All right, now I've adjusted this simulation to flow 110 pounds per minute of air at 40 psi, because this is where I expect the engine to operate at peak output. Now, I was expecting to see that the air would start to back up in the primary plenum, causing it to distribute more evenly into the secondary plenum, but we are not seeing that. It is still heavily favoring the rear cylinders, and I think I see where the problem is. I think this wall here is a little bit too sharp of a corner for the air to turn. You can see very clearly, if we look at our traces, that the air becomes separated from this wall here. So what I'm going to do is I'm going to adjust the design to bring this wall out and bring the air in more gradually in this location to see if we can improve the distribution. Alright, so here is the mod that I made to the intake manifold right here. Basically, I took this wall from right here, moved it out here, and here are the results. So we improved the overall flow distribution by quite a bit. And now I'm going to actually go and implement this on the real intake to see if it makes a real world difference. So let's go do it. Alright, here is what I've come up with for the modification. I added this little channel right in here that helps to get the air in to the secondary plenum a little bit earlier. I think the root of the problem with this intake manifold on this particular engine is that the plenum does not have enough width for this engine. This is definitely on the larger side for a inline six, and I think if I had the ability to move the plenum out on both ends and give the front and rear runner a little bit more room for the air to distribute, I would not have had to do this. But if you're in a case like mine, you may have to do this to your intake manifold in order to get good distribution on the front two cylinders. Additionally, when you weld this wall in here in the front, definitely have to run it at an angle, assuming you have enough room around the front cylinders. You definitely don't want to weld it in at a vertical, as we saw in the simulation. So now that we have the modifications made to the intake manifold, let's put it back on our procharger, lathe, flow tester, and see how the results have changed. Wow, that made a huge difference. As you can see, it is much more consistent, and that is what we are after. So, CFD for the win. All right, guys, that was a lot of work to figure all that out. Frankly, I have way over a week into figuring out how to make the CFD simulation work. I was trying all kinds of crazy stuff, and and I'm kind of glad that I did. I learned a lot, and hopefully you guys learned some stuff as well. What amazes me is that people were able to figure this technology out long before computers had the ability to do what they can do today. And it's amazing to me that they were able to develop such a cool technology. I'm excited to see how this intake manifold performs when it is actually running down the track. But to see that, you'll have to continue to follow this build, and we'll show you how this intake manifold works on the racetrack. So with that, I'm going to end this video off here. If you enjoyed today's video, maybe go check out our other videos on this build. And with that, make sure you like, comment, and subscribe. Share the video with a friend. See you in the next one.